All right, so now I'm going to do a randomization hypothesis test. This kind of goes with 6.2 HT. I'm going to do the same problem that I did using a distributional approximation, but using a simulation method. So I'm going to go to randomization hypothesis tests, and I'm going to select test for a single mean. And then my data set is not in the dropdown, so I need to upload it. So I'm going to do that. And pick the right column. Okay. So here's our distribution. For that one, we had found a mean of 38.44 and a standard deviation of 9.83. So we're seeing that same thing here. Looks like we got one person who's 68 years old. We've got one person who's 22 in that particular sample. And then we need to set what our null hypothesis is. And our null hypothesis here was that the mean age of runners, we wanted to see if it was different than 36 years old. So I'm going to put 36 in here. And I think we were actually trying to see if they were significantly greater than 36 years old. So I can click generate one sample, and this is going to find a randomization sample. It's going to shift the data over as if it was with the mean of 36, and it's going to compute one sample. And so every time I generate a sample, this is if the null hypothesis were true, this is what the world would look like. And then I could click generate 1,000 samples, and it would create this distribution for me. So this randomization distribution is centered around 36 because that's our null value, and the randomization distribution is always centered around the null. But then we're interested in how extreme our observed test statistic was in the context of this distribution. So our observed test statistic was 38.44. So that's just about here, right? Right around 38.5, maybe, a little bit less. And to me, that looks like it's pretty extreme. If I had to calculate the proportion that was as extreme or more extreme, it would be quite a bit. But we can get StatKey to actually compute the p-value. We have to pick if it's a left tail or a right tail. In this case, we're on the right-hand side, so it's going to be a right tail. And then we have to specify what our test statistic was. So in this case, it was that 38.44. And now I get a p-value of 0.014. So I would reject my null hypothesis, and I would say we have evidence to suggest that the true mean age is greater than 36 years.